Hi everyone. Today's session we are going to cover how the journey for Spark New Zealand in towards a data science transformation and an AI transformation. Now, across the world, what we hear is that there have been many opportunities where data scientists have gone into organizations and done something wonderful as well. And this is one of those stories where we started very small and we as we learned through, we realized that data science needs to be done in this particular way in order to feel the full impact of the benefits that can be given to an organization overall. So this is me sharing a part of our journey, a part of our learnings, and then we're say helping out the rest of the community to say, okay, how do we go ahead with this? So before we start, a lot of people across from the APAC area might be thinking, okay, who are these guys? Yeah. So who is Spark effectively? We are from New Zealand. We are the largest telecom and digital services business within New Zealand. By that, we mean we don't just provide you telecom services for your broadband, your mobile, but we also provide digital services on top of it. So we have been launched many services, for example, entertainment ones. We had a local version of Netflix that we had created. We had created Spark Sports, which was more like a sports streaming channel. And at the same time, we also release products within digital security, collaboration, and so on as well. Sometimes we partner with other companies like Microsoft and so on in order to provide those services for New Zealand businesses, which can help them win big. Our purpose for Spark is to help New Zealand win big in a digital world. Now, what does that mean? It means that we want to touch the lives of every New Zealander and help them to achieve their dreams, whatever way they can through a digital life that they have. Okay. Now, as you can see, we are not just Spark. We have a complete business group as well. We have other companies like CCL, Curious, Levin, Digital Island, and so on, which are part of our group as well. So we are not just a single company. We are a group of companies across B2C area, B2B areas, and and other businesses as well. Now, I had we had joined. So Spark actually started creating a data science practice around the time of 2018, 2019. And at that time, it had a set of opportunities which could help data science to really scale big and grow over there. Now, what was those opportunities and what were those challenges as well? So one of the main ones was telecom is a highly becoming a highly competitive area. So for example, in New Zealand, broadband can be sold by multiple companies. Energy companies also sell broadband. There are telecom companies as well. There are other companies which also sell broadband and telecom services over there. So licensing is much more easier in comparison versus to the rest of the world. Now, what that means is that it means very good things for the customer because pricing is low, but at the same time, for telecom companies, it also brings a lot of challenges in terms of competition over there. And at the same time, as you might see, the cost of marketing and marketing budgets was quite high. So there was a lot of pressure on different areas of the business to say, how can we reach to a customer? How can we understand them better without, or say, spending the entire world trying to get a message to them over there? And that was the second point, which was the business was struggling a little bit to really understand what does New Zealanders want and how do we push that, or say, to a single customer level. At the same time, when we started the journey, what we realized was there was a limited understanding of data science and what data science can do for the organization overall. There were a few models that were produced, but mostly churn models, but they were, was it under maintenance mode. So every week, what say when we used to run, there used to be something or the other used to go bad, and what say we had to maintain over there. And some of the models also had a very shortened life cycle because the goals that were defined for them were not very clear when we started. It might be that we have a very high level goal in mind. Can you create a model for that? We did. We tried it out for a few months and then we realized, okay, it's not actually achieving what they wanted over there. So that's why they had a very shortened life cycle as well. And at the same time, moving from small scale prototypes to productions took a lot of time and effort, which was a major challenge overall, which is around, okay, we've created this prototype, now to productionize it takes 2, 3 months. Okay. Well, that's not really helpful over there. So under these challenges was something that we were facing when the data science practice actually started kicking off in 2018, 2019. Now, then the question that was placed to us was, how can Spark use data science to create a sustainable competitive advantage? So the question was no longer around whether data science is useful or not, but how can we use it to actually create a sustainable competitive advantage over there? And in order to create that, we had to resolve all of the things that we had mentioned in the earlier ones, which is around faster pathway to productionization, more reliability, better life cycle of the model, and at the same time, how do we get this thing, better improvements in the model itself as well. So what we wanted was we wanted data science and AI to become a catalyst for change and move data into the front seat. We wanted data science to be in the front seat over there. So previously, what we had was we had a service model. Somebody came to us and said, okay, can you basically create an ad hoc request for us, do some analysis, or say create a small model for us? What we wanted to move towards, that we have moved towards today, is a product model, which is reusable assets, which are built collaboratively with the end user over there. So we are not building it alone, we are building it in collaboration with them. So they have a ownership as well. A financial approach change was we moved from being used as a cost center towards where we are a business cost towards a profit center, where for each model that we productionize, we try to track what is the investment that went into it and what were the outcomes that came from it. That also helps us in the learnings to say, okay, in the next future ones, where should we invest? What were the learnings of there and what should be very clear for us? And that also helps us to have a much more productive conversations in times productive conversations with our senior leaders as well, because they no longer see it as a cost center where, oh, this is a cost, we have to reduce costs or things like that. No, they see it, okay, how much profit can you bring on the table? What are you proposing over there? What is the business case behind this particular data science model or this AI that you're producing? And similarly, in the operating model, we've changed teams enabling incremental growth through behind the scenes earlier, but now let's say we are at the front seat. We are actually working with the stakeholders closely with them as a part of their teams and trying to drive how do we drive innovation and growth within those areas. Now, one of the things to look towards over here is the data science lifecycle management component overall. What we've generally seen is that managing and governing data science products, most of the focus of the tools and the teams is in the prototyping stage, where many models are created, processes, and built at a fast pace. Substantiation is somewhat less, around 30%, and operationalization is less than 1% over there. But if you look at the value for a business, the value for business comes over here, doesn't come over here. So why are our tools and teams not focused on an equal manner over here as well? And that was a challenge that we faced when we started the journey with with data science at Spark in 2019. Now, what we realized was there are three main components to it. One is the right modeling tools, what are the right processes, and what is the right governance we need to create in order to move more process or more value for business as we come into operationalization. Um, Now, just to give you an idea about the machine ML, so here is where the MLOps maturity model comes into place. If you look at, there are three main components towards it: modeling, process, and governance. What we started was somewhere in level two, where we had a few things on. We didn't have a few model dependencies were understood. We didn't have any experiment tracking. CI/CD wasn't in place for models. We had a bit of ML infrastructure which was on premise over there. Model explainability wasn't considered, and model releases were not tracked over there. But we had few components over, so we were somewhere in level two. Now, I would say in today's world, we are somewhere between level 3 and 4, which is around 3.5, where we have CI/CD pipelines for most, and we have code reviews in place. We have comprehensive MLOps pipeline supporting change management as well. We have explainability within our for most of the models, And also we have predictable and auditable outcomes that we have produced as a part of it. So that journey from level 1 and 2 towards level 3.5 to 4, say, is what we'll be discussing, and what are this architecture and the tools that we have used in order to achieve it. All that. Now, in order to achieve this, what we've done is we've brought a major change in architecture and an approach to achieve level point 3.5 maturity. So if you look at this diagram, what we have is we have different components over here. So we start with our experimentation and model analysis, which is one over here. Then would say for our CI/CD pipeline building and deployment, we have level 2. But what we also have is the model serving, or the model registry, which requires the model training, evaluation, validation, and then registration of this, and finally the model serving as well. But what people forget is that if once you have the model served, you also need to look at the performance of the model. And that needs to feed back again into your automated pipeline that you're creating over here. And at the same time, there is a large dependency on the feature store as well. Because if your features are not good enough or you're not updating them properly, then all of these will fail. What I'm going to take you through is what are the different tools that we have used in order to create or in order to stitch this particular architecture on our side. So for the experimentation and this thing, we are using VMs for our current packages. For source repository and source code, we are using ADO on our side. For the entire automated pipeline, what we're using is Azure Machine Learning for a lot of these components over here. So Azure Machine Learning is also a model registry and a ML metadata store underlying it. For our feature store, we are using Snowflake. So we are creating our features and also consuming it from Snowflake itself through from Snowflake to Blob, and then once I move into Azure Machine Learning. And the other component, important one, is around performance monitoring. For this one, we are currently using a tool called Arise over there, which helps us to give a visibility of how are our models performing. Are they actually degrading? If they are degrading, then it should automatically trigger an automated pipeline to retrain them. Are there, would say, any biases, or can we explain those results as well, which are being pushed from here, and you have a visibility on the Arise platform over there. So Arise is basically acting as ML observability. It's not just showing the performance view, but it's also showing that what are the missing components that you need to observe, or what are the missing components that need to be surfaced in order for your models to perform better over there. Are there any hidden populations that you can target in order to perform your models better or not? So one of the other components in order to help our teams in scale and be much move to that higher maturity level, we've introduced model cards on our side. Now, what do you think that, okay, what is a model card? So what we've done is the model card has the details, a lot of details regarding the model performance. So for example, here is an example of a device propensity model, which is used to predict when is a customer likely to buy a new device. So it will basically ask, say, details. Okay, what is the device propensity of what is device propensity model? Who are the users of it? What are the limitations of the model? How can we improve the model further? Then it also gives details regarding what is the classifier used in the model? What are the input features? What are the other details that we might have over there in order to explain it better? And at the same time, it gives a validation data set analysis, why customer X and why not customer Y, what are the other metrics that we can compare it against, and how is it performed against other metrics if we have not even considered those but still want to evaluate. At the same time, it gives a bit more explainability around the model performance as well. And finally, we also provide, are the models biased or not? Are they fair or are they not over there? So these are some of the components that we've introduced as a part of our model cards design along with the infrastructure or the architecture that I've shown above to you. Now, the other component that I wanted to talk about was around data health. What we found is that data health is foundational to the success of any data science model. So we've tried, and data health needs to be monitored for multiple reasons. One reason, as I mentioned, that it influences on training and ultimately leads to better results. But at the same time, what we also see is that most of the problems that we had for model performance were not related to the model itself. Once we put it into production and it had automated retraining components and so on, it was more related to data health. Either the data was not refreshed, or would say the data was have giving a lot of nulls because the source system wasn't working properly and so on. So what we realized is that every time our models triggered an error, a large component was because the data health was not being monitored, or we didn't have a good visibility. At the same time, what we also realized was as AI becomes more core to the organization and starts making a lot of decisions for the organization, it's very critical that we have a visibility of uh, how is it performing and how is it, are there any risk to this performance going ahead? And that's where normally what happens is if things are performing well, humans go into autopilot mode. But we needed something to say that, okay, if the data is not working properly or if it's not doing well, then what is the risk that we are facing? And how do we mitigate that risk more as we go ahead? At the same time, what we started looking was that what are the data quality dimensions that can help us improve the health of the models itself over there? How can we look at data health in order to improve our data science health or model health? One was around accuracy, trying to see whether data reflects reality. So are there any, we are expecting 100 nulls normally for within 100,000 rows. Now we are getting increasing it to 1,000 nulls. Does that seem right, or does it seem that data is getting corrupted? Timeliness, is the data available up to date or not? And this is quite important, especially when you're giving daily or more live data science updates or predictions on it. And the consistency, uniformity across different data sources. If certain data sources are unreliable, should we be actually using those data sources in our models over there? And that's another important component to think about, because if it's unreliable, then your model will also become unreliable. And rather than that, sacrifice a little bit on accuracy and try to use sources which can be much more reliable in the long run for you. Now, I'm a big fan of Dilbert, so that's why I would say this is more around, okay, how how I would say data accuracy is being dealt with over there and how it is considered. You will always assume that data provided to you is true until somebody questions it or until somebody starts asking questions around it. Now, as a part of the data monitoring architecture, what we have done is we have using a solution called Monte Carlo over here. So in terms of data sources, we have Oracle, Salesforce, Google Analytics, all of them feed into the Snowflake to Snowflake. Now we use Snowflake as a mix of data lake and warehouse both over there. And what it does is from Snowflake, it goes into Power BI as our visualization tool, BI visualization tool. But at the same time, this data, some metadata, query logs, and metrics is collected into Monte Carlo as a tool, where Monte Carlo is collecting the data, is pushing that into a monitoring dashboard, and at the same time providing alerts based on different situations. So if your data hasn't refreshed, then it can send out an email, it can send you out a news notification, Teams notification, or what is it can create an alert on Arise to say that, okay, this data is not refreshed, you need to possibly do some retraining or something of that sort. So we are creating those feedback loops to monitor data health and then also push it to the right directions so that actions could be taken accordingly in order to follow up with them. Now, here is an example of what a product like Monte Carlo provides. This is number of incidents that we are facing, how much is the volume, what is the field quality, any scores around that, and at the same time, freshness and volume and so on. These kind of indicators can be pushed into different areas to see how can we use some of these things on our side. Similarly, these are some quality metrics that you can possibly see for each of those areas, which is around how many incidents have happened and so on. Now, what we want to do is for each model, we want these kind of indicators to see the tables that it's being feeding from. Does it have the right data health, or would say has it been deteriorating over a period of time? So that then we can make a decision that okay, should we continue with this data sets or do we need to change them because this data is becoming unreliable and the outcome of this can be very disruptful for the business. Now, before I move ahead, are there any questions in the chat?
No, I don't see
No,
any posted yet.
no, it's no, not a problem. Thank you. Similarly, what we've been trying to do is that we have been trying to also create a performance dashboard for the different campaigns. Now, as you can see, this can be the performance for the different models that we are using and how are they performing in terms of a financial component. So in the earlier slides, as we have shown you, that a large area for us moving from a cost center to a profit center was actually showing that we are not just going to create models and forget about it, but we are going to work with the teams to help realize what is the financial benefit that we are gathering from those models and quantify it. So, for example, here, some of these models have an uplift of 68% and so on. And that's the kind of benefits that we are driving towards the business. And that's why we're not just part of the cost center, we are part of the profit center because we're helping them realize the benefits as well and monitor and capture that value. Yeah. Now, just to talk to through you to that. So, if as you have seen the different examples of this, how has the evolution of data science at Spark been? So, as I mentioned, when we joined in FY 1920, most we had just two or three machine learning models. The lifetime was less than 2 months and was used by the marketing tribe in particular, and it had very limited visibility at that time. As we went through that journey, we've grown from 3 models to 45 models. The lifetime, would say, of those models has changed to 1 year from 2 months. And would say rather than just working on one tribe, now we are working across 3 tribes. Now, tribes over here, because we're using agile terminology, would refer to business areas within our organization. And at the same time, there was a huge demand of observability from different stakeholders. And that's why we started including machine learning observability, explainability, fairness, bias over there. By FY 23-24, we have more than 80 plus machine learning models. The lifetime has increased to 2 years, and we have projects across the organization over there. So we have projects in HR, we have projects in network, we have marketing, and so on over there. We've grown from a team of 3 people, 2 or 3 people over here to 25 data scientists and so on over this period. So we've grown in size and this thing. But at the same time, what has helped us is with that scalability the architecture that we've shown, the scalability has been much more easier. Otherwise, if we would have used the same system or the same kind of approaches, we would have to scale in team numbers much more larger. At the same time, the system has also created a lot of transparency. So data scientists can collaborate with each other, they can share their code, they can learn from each other, they can share what features have helped in their machine learning models and give other opportunities to try it themselves as well. So the infrastructure has also led to a lot of collaboration and transparency across the business overall. Now, the next step, the next evolutionary step for us is to start looking at what does this mean in the long run. One of the areas that we see of growth for ourselves is around how do we create an AI command center. So what we want is the business to start, what we want is that the business tomorrow wants to understand what is the risk of AI going haywire, or what is the risk of AI saying that, okay, no, this particular model has is not working, what do we do with it? Or we want to increase sales, how can AI help us, or which models can help us over there? That's why we've thought of an AI command center as one of the core things that we want to develop. Now, what are the different elements of that AI command center? One is around the financial info. So what is the revenue gain? What is the model development cost? What are the operational costs? And what is the return on investment? This financial info can help us to really drive good outcomes for the model, and it also helps us to realize how much effort should be put in each of the models, and where do we need to actually push back and say, okay, this model is not worth the value that we are looking for. That's why I would say we'll possibly not continue with it. Similarly, what we want to see is how do we create an AI command center which helps us to monitor the model health and the model performance and model monitoring. So, with regards to model health, are we maintaining the documentation properly? Is the testing quality being done? Is the code quality also good? Audit logs are there or not? Model robustness is there or not? And at the same time, what is the model monitoring component? Do we have explainability? Have we done a fairness assessment? Have we created alerts for data drift around it or not? And these two components become quite critical when we're looking towards the future, where AI is becoming more prevalent within businesses. But at the same time, there will be a demand from different areas to audit those AIs as well, especially in public sectors and so on, where a lot of these components can have large scale effects. So we are thinking about creating those capabilities where we can audit our work as well, rather than just saying we have created a model and deployed it. At the same time, as I mentioned, data health is quite critical in order to feed into the AI command center. But what does it, as I mentioned, is what these four components are feeding information into the command center. What will the command center then actually do? What is the execution that it can do, or what can humans do at the execution center? The action center is then becomes quite critical. From the action center, people can decide whether a model requires retraining or not. If it's not on auto training or so on over there already, is the model needs to be archived, that this model is no longer useful, we need to possibly move it away. Does the model require review? We still feel understand that okay, the use case is still there, but the model is not performing. Do we want to actually try and go back and see whether we can rechange the model or completely? And at the same time, because data is being created and we have new features coming in from different areas, there can be an opportunity for model enhancements as well, where we say that, okay, these features were not available earlier. How do we incorporate these features and try it out and see, okay, whether it gives us any improvements or not over there. So this is what the action center could look like, which is around making decisions around the models and trying to see how can do we need to retrain, archive, review, or do we need to enhance it further with new features? Now, this is just a view of a high-level cloud-based architecture that we've created, which is around data ingestion, storage, advanced analytics, and this is the observability and traceable monitoring that we are using over here. Now, one of the important components to consider over here is that what does the telecom of the future look like? Now, what I've talked to you about is mostly around the AI infrastructure around predictive AI. But with generative AI coming into the mix as well, the telecom of the future looks very different. It has three, four different components. First one is that we have to reimagine the engagement that we will have with our stakeholders. It will help us to get better, richer interactions with the customers, better call routing for call centers. We have creative marketing, and at the same time, smart AI-driven digital services for business, and at the same and network optimization as well. But what are the AI capabilities that will be required in order to achieve this? AI tourism is an important one, which is AI trust and management, which will be more on explainability, fairness, bias assessment, and so on. But there are some new components that will come in as well. I've already talked about generative AI being an important one. Computer vision can come into place as well. Graph databases and reinforcement learning are another component which are becoming quite important in many different cases, especially when your data is very linked in different ones. And what are the advanced analytic capabilities that you can use, or some of the use cases that you can use based on what we have said in terms of reimagined engagement? What does that mean? One of the important components is being going in the future is personalization at scale. You will have more personalization for your marketing, and at the same time, you'll have better digital services and more digital services coming in over there. that was all from my side. Thank you. Do you have any questions?
Um, I don't see as of now, but probably someone's still typing it in. We have still 3 minutes, so dear attendees, if you have any questions, please type the questions here on the or on the live@odesc.com. In the meanwhile, I will like to remind you that there will be short survey following right after the session ends. So if you have any comments, questions, feel free to drop your feedback out there. Additionally to it, Q&A channel on the live@odesc.com. So this is basically the platform where you can find all the agenda and where you can connect with the other people. This Q&A channel will be open throughout the conference. So if you still have anything related, or even if you'll ask the question now out there to Habib, he will answer it and it will be saved. So even afterwards, you can come back and read it if you don't have time in between of the sessions. So please don't hesitate to use this channel as much as possible. Let me check once again whether there's any questions.
Sure.
If not, definitely the questions are opened after the session ends. No, I don't see any questions as of now posted. Maybe someone's still typing it in. Habib, do you have any last comments that you would like to add, or how the people can connect with you, or how they can find all the resources that you probably shared or mentioned here?
Sure. I think a lot of what I wanted to say as a main takeaway for people who are listening to this, one is that data science implementation in different organizations is a journey. It's not going to happen overnight. It takes a bit of time, a bit of trust building with different areas, and it requires an approach where you're not just thinking and saying, I'm productionizing a model, here it is, go and do whatever you want with it, but it's a collaborative piece over there. And that collaboration takes a bit of time and effort. At the same time, what we generally see is that productionization is never on top of mind for a lot of data scientists. But now, with people demanding more, going from the experimentation mode into more implementation mode, productionization is one of the biggest challenges, and maintenance of these models is one of the biggest challenges for data scientists going ahead over there. If anybody wants to reach out to me or this thing, please reach out to me on LinkedIn. More than happy to connect with people and try and understand how they are facing or taking on these kind of challenges as well on their in their own way.